Okay, in today's video, we're going to go over another problem involving freefall kinematics. This is the first video in a three-part series. In this video, we're going to find the final height of the ball when it's projected straight up and comes straight back down with a known initial velocity. That's what we're going to do in this video, part one. In part two, which you can link to right here, we'll find the total time that the object is in the air. And in part three, which you can also link to right here, we'll find the final velocity of the ball or the object when it's down here at the bottom. But as I said, this is part one. And in this part, we're going to find the final height of the ball. Now we are going to project the object with an initial velocity of 15 meters per second straight up. It's going to go up into the air. It's going to stop. And then it's going to fall back down to Earth. And we want to know what is the final height. Well, we know it's originally projected. When it starts, it's 17 meters off the ground. So all we have to do is find this change in height, the change in y, the change in position. All right, to do that, as we've done with all of our kinematic problems, we are going to get out all 5 of the kinematic variables. That is the initial and the final velocity, the change in position, the acceleration, and the time. Now we're going to fill in what we know and what we don't know and what we're looking for. We're given that the initial velocity is 15 meters per second. It's not stated, but you should remember for kinematics and free fall that the acceleration is generally always minus 9.81 meters per second squared. That's the acceleration due to gravity. It's negative because the acceleration vector points down, which is the negative direction. The other thing we know, because we're only concerned with the path of the ball from here to here, because we're trying to find the change in height, when it gets to its maximum height, we know that the final velocity is 0 meters per second. We're looking for the change in height. We don't know the time, and we're not asked to find the time. So therefore, you can see once again, we're given 3 variables. We're asked to find a 4th. We can take all those with us to the next slide, get out our kinematic equations, and figure out which equation we're going to use. You'll remember each of these equations has 4 variables. That means it has to include, the one we're going to use has to include what we're looking for and the other 3 variables. Now the first 3 equations have the time, and the time in them. We don't know the time. That means we can't use these 3 equations. That means we're going to use this equation. Now let's just confirm. Does it have delta y because we're looking for delta y? Yes. Do we know the other 3 variables so therefore we can solve for delta y? We know the acceleration, we know the initial velocity, we know the final velocity. Therefore, we're going to use this equation. Final velocity squared is equal to initial velocity squared plus 2 times the acceleration times the change in position. Now, we're trying to solve for the change in position. So we have to solve this equation for the change in position. First, remember also that the final velocity is 0. So this term, final velocity squared, goes to 0. Now, if we solve for the change in y, the change in y is going to be equal to, we have to subtract the initial velocity squared from both sides and then divide by 2 times the acceleration. That tells us that the change in position is equal to minus the initial velocity squared divided by 2a. Okay? Now we're almost there. We just got to plug in our values. The change in position is equal to minus 15 meters per second squared. That's the initial velocity divided by 2 times minus 9.81. And we get that the change in position is 11.5 meters. Well, we want the final height. It starts 17 meters off the ground, so we have to add, obviously, 17 meters per that, and we get that the change in position, the total height of the ball, the final height of the ball, is 28.5 meters off the ground. Okay, there you go. I think that was pretty straightforward. We drew a nice picture. We wrote down all 5 variables, figured out what we know, what we don't know, chose the correct kinematic equation, solve for unknown, plug the values in, get the answer with the correct units. Thank you very much for watching. I hope you found it helpful. If you did, you can now watch parts 2 and part 3, and then you can subscribe to my channel, get all my excellent physics, chemistry, and math videos, give me a nice thumbs up for this video, and leave me a nice positive comment in the comment section below. Thank you very much. We'll see you in the next video.